On our list, we have Cartographic Coding and the Implementation of the Grammar of Graphics by Cammack from the University of Nebraska, Omaha. Welcome, Rex.
Thank you. Let's see here. I think the cable is loose, maybe. There it goes. All right. Hi, everybody. I'm Dr. Rex Cammack from the University of Nebraska, Omaha. Before I get started, I'd like to, again, as probably done many times over this last couple days, I'd like to thank the NACIS organizational group for putting on one of the best conferences that you can really attend in the visual space. I think it's one of the most inviting conferences, and I just can't stress enough how important it is in our community to have a conference like this. One of the reasons for that is that I go to a lot of other conferences, and I don't feel as free to talk about things that I'm interested in, and I don't feel that creativity is respected as much as other conferences. And I really value the concept of creative intellectual ideas, and I think this conference allows me to do that more than any other. So today I'm going to be talking about something that's kind of a little off the wall. I call this NACIS as my vent outlet. It lets me vent about my job because I don't have to do super formalized research projects and stuff like that. So I rarely ever talk about anything at NACIS that revolves around research grants and money and stuff like that. I talk about things that I probably am most passionate about or I'm most frustrated about. And this one is actually one that I'm frustrated about. So if I go off the deep end, we'll try to mellow out before the end of this. Hopefully we'll get there. So, all right, so for those of you who are not familiar with this phrase, the grammar of graphics, it comes out of the data science field, and many of you are well familiar with the data science field. You work with data scientists all the time, or you work with people who call themselves information scientists. Cartographers tend to have a little bit of a rough edge with these people because they feel like that they're telling cartographers that what we already know a lot of times. I mean, we've been making information graphics for quite a while now, and they'll walk in the room and tell you everything that's completely wrong. And so I'm going to be talking a little bit about the kind of the theory, some of the theories that come from this. I'm trying not to do too much code and too much theory in this, so we'll see where we get. All right, so the general idea here, the overview, I'm going to have a general idea. I'm going to talk about some other stuff, and then at the end, we'll finish this thing up, okay? And so everybody loves this slide because it's the one that everybody wants them to hit the button next, so I'll do that. All right, so my central idea for this project, this is what I kind of put together when I thought about it a couple months ago. I came back to it. I actually didn't re-edit this, so it's kind of shocking, and normally I do. But what I'm really trying to look at, I'm going to paraphrase it another way so you get two exposures to these ideas for me. I'm really interested in how we take the idea in our head and we actually make it into something, all right? Not so much, you know, the theory about communication and the theory about all these other kind of theories we do. I'm really trying to say, how do we as individuals do this? And what we have today is a very different world than we had 25 years ago. So 25 years ago, if I wanted to make an important line on my map, I had to go back to my pen set and get a different pen out and draw that line with a different thickness pen. I had a mechanical way that I translated that idea. All right? It was something very tangible, very mechanical about it. So for those of you who can remember Leroy sets, there's maybe a few of you in here that remember them. And my favorite was Zipatone, which I love Zipatone. Oh, I love the burnishing. All right? Just love it. And actually what was really great, I was in the map display area, and one of the maps in the map display is exactly trying to mimic the process of using Zipatone and photomechanical methods, but they did it digitally. So as soon as I saw it, I just started kind of chuckling to myself going, I should really have that in my talk because it's really funny. But anyway, All right, so let's go on to something more interesting. So cartographic perspective of this, how do we do what we do? Well, we can go all the way back to kind of the simplest definition of this, the cartographic abstraction process. We've got all these different theories in cartography that we either developed ourselves, we went out to other disciplines and grabbed them and brought them back to us and integrated them all together. There's a really simplistic list of that. But this whole idea of that we want to take the world and create an abstract representation of it that gives somebody meaning is important to us as a community, which is interesting because I don't think the data science field sees it that way. And actually, I'm going to try to prove that they don't. All right? So, all right. So the next thing we do is we go to the data science field. We start in the data science field, and we look at what they do. Well, the data science field, kind of interestingly enough, may not ever really think about the real world. They only think about what comes out of their sensor or their collector or whatever it is. That's real to them, all right? You know, I always tell, one of the great things I love about the department I work in is I work in a geography department, and so most of the time the students that I have are actually interested in the real world. They want to go outside and experience it, do like that. At the school I'm at here at UNO, those students are very interested in kind of the an urban, suburban, social environment, right? If I talk about the school I worked at before at Missouri State University, the vast majority of those students very interested in environmental experiences. They're all kayakers, backpackers, mountain climbers. They all had this thing. They came into my class. I said, good, sit down in front of the computer for the next 25 years of your life and don't ever see the real world again. All right, so we kind of have that. So what happens is in the data world, they really kind of conceptually see this data world as we're going to kind of understand that humans are bad, right? And so what's bad about it is that humans can't identify the patterns in their data stream. They're just terrible at it, right? And we are all victims of this. If we make a table of information, numbers, and throw it in somebody, 25% of the people might be able to pull out the sentient information in there, whereas the data scientists love the fact that they can write a computer algorithm that reads through that table, finds it like that every time they find it, all right? And if you don't believe that they can't, then you haven't used Match.com, because that's exactly what they're doing. They're trying to find a match out of patterns, okay? So, all right, so that's kind of where I'm at. So over in the data science field, one of these kind of theorists in the data science field is actually a programmer for Systat, and he did some other stuff. He proposed this idea of what's called the psychological reader model, all right? And the psychological reader, this is the theory part. So if you fall asleep during this part, I'll try to wake you up in a minute. So what he came up with this idea, or it's actually in the literature, kind of permeates it all over, is this predicate literature, predicate calculus, which, to break it down in simplest terms for us to understand, it's really attribute value pairing, all right? It's we have this entity and we have a characteristic of it and we're pairing them together, and that's what this predicate thing is. The real rub in that is in that field, there's two types of predicate calculus that goes on. One where the relationship is assumed true, and then one where it's not assumed true. So we kind of have to, this idea of truth gets put into their theory. All right. So the next thing we move on to is we move on to this the grammar of graphics. Which, interestingly enough, is taking data science and then trying to turn it into pictures. All right. Most of the time in their world, they're trying to create graphs. Cartographers have been making graphs for a while, but that's what they're trying to do. And so what's interesting is if you look at the development of this idea of creating grammar, trying to create a grammar for explaining how graphics work, it goes all the way back to one of our founders too, Bertin. He starts there, and actually I didn't put all the references in there, but if you get all the way down to the end of the reference chain that they have, the second to last one is Alan McEachran. And then they have some people, he has a person after that in his kind of justification for this. So they're keenly aware that other people have been working on this, have ideas about it. They may not have found all the ideas from our discipline, but they at least have some of them. All right? And so when they work with this theory of representation and information modeling, that's the next step of their process. And then they create this model, this pairing, this predicate model. And through that, they then try to say, okay, if I create this predicate model, I should be able to flow through these group of nodes and be able to do what a human does with my computer algorithm, all right? And that's pretty much what it is. And they're trying to extend this not just to finding the patterns, but then how do they portray the patterns, okay? All right, so an example from data science, the graphic would be, if you kind of boil their whole theory down, is they try to write a sentence, or they try to have a phrase that says this is the grammographic. So, and it's very data-oriented, so it's very austere, I would say. So build a pie chart from data in a frame. That's a grammographic statement, right? And then what they would do is then they would write basically in their grammar a story that would wind up generating their final illustration, right? That's the theory behind it, okay? In cartography, if you wanted to use that as for a cartographic example, I put one in there. You know, you make a chloropleth map from this data set on this page, or like a general reference map over this entire area, or something like that. Okay. All right. So why am I discussing this? I know that I have 20 minutes. I don't want to completely waste your time. I hope that one person in here, other than me, gets something from this. So I got to kind of explain why I'm doing this. And so one of the reasons why I'm doing this is I'm really interested in the thing I talked about very early. How do we make the graphics that we do, how do we take that idea and we turn that into something, right? And the reality of it is, in the data science world and the cartographic world, we basically have only two methods now. There are some people, and there's some great illustrations, again, in the map displays, where people are doing mechanical stuff, but there's really two ways. You're either a coder person or you're a graphic user interface person, right? That's how you do it, right? And in the data science world, there's no such thing as a graphical interface approach of doing this. You have to do it all by writing computer code. I do have a caveat down there, Tableau. Whether that's a data science tool or if that's something else, they're trying to play in this inner space in the market. That is a graphical user interface, so I know that there's some of that out there. So that's kind of the reason why I'm trying to do this, is that data science has no choice in code. Cartographers do have some choice other than code. What's interesting is that once you get that you create that structure, then you create groups. All right, or communities, the coder community versus the GUI community. I think here at NACES, I always feel like it's a really good mix of people who are willing to work with both. Most cartographers are willing to work in both worlds. They can code stuff, they can do stuff. My students are not. My students hate code, right? They hate learning code. They haven't really had much coding experience. Luckily, I have a colleague of mine that forces them through about 90 hours of computer coding before they get to where I need to have them write code. And actually, for me, where I have them write code is actually in data analysis, not in making maps. I teach a data analysis class, and so I have them write a lot of code. And a lot of these ideas come from this class and me dealing with the data science solutions to some of this stuff. So, okay? All right. So, another question we have to ask is, are people in cartography blank coders? All right? You fill in your word of choice. All right? I think they all apply in one stage or another, even to myself. So the question is that we have to ask here is we have to ask ourselves, you know, as a community, are we all working together and doing the same thing? So I think we have to go outside the cartographic community to answer this problem and to answer this. And I think we have to go to a higher power. And there's only really one visual philosopher from the last century that we can really trust to give us any advice on this. And that's, of course, Bob Ross. All right? For those of you who don't know who Bob Ross is a great artist and a great philosopher. And so here's Bob Ross's answer to that question I just posed. And some of these quotes here can be directly related to that. And I know that my referencing to Bob Ross is a little weird. It's a little weird. I admit that. You should, but you can basically change your life by watching Bob Ross, right? And so go on iTunes or get the DVDs, or of course, you can go to a public television station in the United States that's filling time on a Sunday afternoon, and you'll find Bob Ross, right? But I mean, there's a whole generation of people in the United States that believe in the philosophy of Bob Ross. But I actually think these quotes are funny and related to this concept. But there's actually two quotes I think that Bob Ross is famous for that I think kind of actually played a part of this, right? And I should really read them. All you need is paint and a few tools and a little instruction and a vision in your mind. And that he's famous for saying this over and over in his TV show. And I think that's what cartographers are, right? My question is, what are the tools they have? What tools and what kind of instruction do they have? That's kind of one of the things I'm interested in. The other one, I changed that one I rewrote it for geography there. I didn't rewrite the second one. I could think of anything more rewarding than being able to express yourself to others through painting. Exercise the imagination, experimenting with talent, being creative. These things, to me, are truly the windows to your soul. And maybe that's why this conference and this group is such a cool group, is because many people have this in mind. Okay? All right, so let's get back to the grammar graph just for a second. The grammar of graphics theoretically was put together by several scientists, but in practice was put together for the R libraries by a guy named Hadley Wickham. He created a thing called ggplot2. ggplot2, here's how they translate. Really what Hadley Wickham's trying to do is using the grammar graphics metaphor to explain how he wrote his package and how you're supposed to interact with it. All right? So here's an example of his code. He finds the grammar is understandable. You identify an action, ggplot. You use some data. You set up some aesthetics with it, and then you make a graphic type. That's basically his grammar, all right? And it repeats over and over again when you're working with R and trying to do graphs. So again, a ggplot2 graphic example that I stole off the internet. It's average, but it's pretty cool. Other coding sources that you can find grammar graphics related to are these, all right? And the Cartographic World is there. So I have to actually skip forward, not a surprise. I couldn't believe I actually had more than 10 slides. All right, so I'm going to, here, there's my conclusions. Yeah, so here's my conclusions. So basically the idea is that the grammar graphics is very powerful. It could be used in the graphical, I think it could be used more than just in the coding environment, but can also be used in the graphical user interface environment. And pretty much, I think it's a new source of ideas and new source that cartography in our field can really utilize. Whether they're good ideas or bad ideas, at least they stimulate us. Okay? And those conclusions are secondary. And I'd like to thank everybody for being here.